Okay, in the last video we had an introduction to the gamma function, and here we want to work with it just a little bit more. Using our definition, what would the gamma function of 1 actually equal? Here this would be equal to integral 0 to infinity. That's x to the 0, so that's just 1 of e to the minus x dx. And that's just going to be very easily minus e to the minus x going from 0 to infinity, and that will equal minus 1 over e to the infinity minus 1 over e to the 0, and that is 0. E to the 0 is 1, so here we have minus negative 1 equals 1. So the gamma function of 1 is 1. With other whole numbers, we can work them, remembering now that what we had derived in the last integral, or the last video, that the gamma function of n plus 1 equals n times the gamma function of n. We derived this relation in the last video. So let's say that we want to define the gamma function of 8. Well, let's see, that's the gamma function of 7 plus 1, and that would equal then 7 times the gamma function of 7. Okay, and this right here would be the gamma function of 6 plus 1. So this will be equal to 7 times 6 times the gamma function of 6, and we can write this as gamma function of 5 plus 1. So this will equal 7 times 6 times 5 times the gamma function of 5. And let's see, we can keep going like this. That will eventually come out to be equal to, if we keep going all the way down the line, we'd say that the gamma function of 8 equals 7 times 6 times 5 times 4 times 3 times 2 times the, actually we're going to have 1 times the gamma function of 1, and that is 1. So we get that the gamma function of 8 equals 7 factorial. And again, that was derived simply by using this equation repeatedly throughout the process here. Or in other words, then, we can say that 7 factorial equals the integral from 0 to infinity of x to the 7 times e to the minus x dx. The gamma function of 8 is this, x to the 8 minus 1 power. The gamma function of 8 equals 7 factorial, so we can say that 7 factorial is equal to this integral here. If we had, say, the gamma function of 10, divided by the gamma function of 6. Well, that would just be equal to 9 factorial divided by 5 factorial. And this would be equal to 9 times 8 times 7 times 6 times 5 factorial divided by 5 factorial. Or that would just simply be equal to 72 times 42. So those are just some of the basic properties here when we're dealing with gamma functions of whole numbers. What about fractions? In a future video, it's going to take a little bit of work, but we will show that the gamma function of 1/2 is equal to the square root of pi. And then that will enable us to work with gamma functions of fractions as well as whole numbers here. So this is just kind of a sideline here of some of the basic properties of gamma functions. Come back and join us in the next video, and we'll try to get to some more complicated topics.